Hello students, welcome back. Let us see this very good problem from JAM 2025 question paper. So here they have given you unpolarized light passing through the air and incidenting on the glass whose refractive index is given √3 and the incidence angle is 60 degree. And now they say the amplitude of the in plane electric field component of the light is 4 volt per meter and out of the plane electric field component is a 3 volt per meter. After passing through the glass slab, the electric field amplitude is. So when light passes through the uh, glass slab, we need to calculate the electric field. So this, you see this figure. So what is they saying? They're saying that you have light falling. So this is the unpolarized light. So unpolarized light has a two component. One is called S polarized component, other is called P plane polarized component. P polarized component, the electric fields are in parallel to the plane, while S polarized components are the perpendicular to the plane. So now the angle of incidence is 60 degree. So angle of incidence 60 degree. If I calculate the booster angle tan theta b, if I calculate the booster angle, which is given by tan theta b, is defined as a n2 upon n1. N2 is the glass refractive index and this is the air. So this comes out, theta b comes out 60 degree. So basically the incidence is at the booster angle. So what happens when light falls, an unpolarized light falls on a booster angles? So to see this now, because light is falling two components, so whenever it falls on a booster angle, what happens? All the reflected light is perfectly polarized. The reflected light is perfectly polarized. So these components get here, and these parallel component passes through without any loss. That means there is a these parallel component do not get reflected. They are reflected, reflection amplitude 0, and they pass from here completely. And this component as component, so this is a parallel component, this is the parallel component, it is called p polarized component, and a perpendicular component is called s polarized component. So s polarized, partially reflected, partially transmitted. So this is the partially polarized light, and this is the completely polarized light. Now we need to calculate the amplitude here, amplitude of electric field here. So as I told that, what happens? Parallel components, they come as it is here. So this is a 4 volt per meter, that parallel component will come as it is. You can understand with these equations. You can use this equation, or you can use equation and calculate the amplitudes. Let us calculate the amplitudes of reflection, refraction, transmitted, and transmitted parallel component, and transmitted as component. So first let us talk about the parallel component RP. So if I calculate the value of RP, N2 is a glass √3. Theta I is what? Theta I is your 60 degree incidence, 60 degree, minus N1 is 1, and cos theta T. So theta T you can find from the Snell's law, and sine theta I equal to N2 sine theta. I'm writing R here, it's a transmission way I'm saying, so I'm writing theta T. So sine theta T becomes 1, this is √3. Sine is, this is N1 upon N2, so this is 1 upon √3, and this is 60 degree, so √3 by 2. So this is sine theta T, so theta T is half, sine theta T is half, so this is theta T is 30 degree. So your cos theta T is 30 degree. So this becomes cos 30 degree. Similarly, here you have N2 is your √3, cos 60 degree plus N1 is 1, and cos 30 degree, cos 30 degree. So let us calculate the values here. So if you calculate the values, this comes out, cos 60 is 1 by 2, so √3 by 2 minus cos 30. Cos 30 is also root 3 by 2. So this is half, and so it becomes 0. So here you know don't want to calculate. So this is root 3 cos 60. Cos 60 is half. So root 3 by 2 plus uh, cos 60 is half, correct? And here cos 30 is root 3 by 2. So root 3 by 2. So this becomes 0. Okay, so this becomes completely 0. And if I calculate that uh, parallel component, okay, parallel component means this parallel component passes as it is. Okay, let me draw it, make it bigger. So this is the parallel component. So this is the parallel component. They transmit without any reflection as it is. So this is the magnitude is 4 voltmeter. So 4 volt per meter is coming. Perpendicular component, they partially reflected and partially transmitted. So we need to calculate their amplitudes. And I told you this is the completely polarized, this is the partially polarized. So now let me calculate the values. So now if TP I calculate, TP should come because this is coming 0, this coming 0. So this should come 1. Let me check it here. So this is 2, n1 is 1, cos theta I root 3 by 2, and n2 1.5, n2 is root 3, cos theta I cos 60, cos 60 is 1 by 2, and here you have again n1 is 1, cos theta I 30, that is root 3 by 2. So this become 2, so this become 1. So this is, I told, completely pass without any loss. Now let me calculate. So what is it? What does mean? What is this meaning? So your TP is what? TP is your E ratio of transmit component and ratio of incident component, which is 1, That means ETP is 4 volt per meter without any loss it coming. And now let me calculate for S component. S component, the equations are there. So S component, actually we only want the transmission component, we don't need to calculate this one. So transmission component we can calculate TS 2, n1 is 1, cos theta I, that is root cos theta I, this is half 60, half, and then you have a n1 1 cos theta I, again half, plus n2 is root 3 cos 30 root 3 by 2. So this become 1, and this become half and 3 by 2, so become 2. So this is TS comes out half. TS values comes out half. So half का मतलब क्या हो गया? You have TS is equal to ETS upon E incidence S, whose value is half. Now EIS is 3 volt per meter. So this become 1.5 volt per meter. So now have a both component parallel to plane and perpendicular to the plane, and now I can find the total amplitudes. So amplitude of transmit electric field will be 4 square plus 1.5 square, that is 16, plus 2.25, that is 18.25, and now this is almost equal to say 4.2. So the correct answer for this question is 4. Value is 4. The amplitude is 4 volt per meter. That means we are assuming that uh, perpendicular component almost all are reflected, because that depends on angle. At this angle, we assume that this is almost in fact this come 1.2, 1 point half is coming. So already is less, 3 is there, half of 3 is 1 by 2. So total remains 4 volt per meter, which is the parallel to the plane. So this is the answer, 4 volt per meter is the answer, and this is given as I think option B. So the option B is the correct answer for this question. Hope you like the solution. Thank you very much.